This is the reason why I had to do a new frame. I wanted a 10mm taller conrod, and to make room for that I knew that the engine had to be taller, and that was simply not enough room in the Honda RS250 chassis for a higher engine. So that's the reason why I made a new frame. Here is the 10mm taller conrod together with the 80mm stroke Husaberg crank, together with the 35mm wrist pin. The taller conrod I hope to reduce the side forces and also reduce the acceleration forces in top dead center and bottom dead center. Altogether I hope that this will relieve the stresses on the mains a little bit. And with the smaller stroke I have compensated a little bit with 104mm bore, and 100mm is stock. So, and here is also a JE piston, 104mm. I will back off a little bit from the compression as well. Before I was running insane 14.7 to 1, and that was no good idea. So this is more like 13 to 1. That will be quite okay, I think. Here we have the head packer that gives the additional room for the taller conrod, and also the cylinder sleeve is put in place, and also the piston. So now we are ready for a clay check to check the clearances in the valve pockets. And while I have it on open on this side, you see also this this thing here is a venting pipe, which adds another crankcase ventilation with tank foam inside. And that is because before I have had a very high compression, so there was a lot of blow-by. So the stock crankcase ventilation wasn't enough. So I manufactured this one. It was a little bit trick to fit it where the electrical starter should be, but it worked beautifully. When making a taller conrod, I had to make it in corresponding to what I could extend the cam chain with, which is 2 links. So that means 1 link's extended height on each side. So I needed a cam chain with 2 more links. So when buying another cam chain, I also upgraded to quality with, still from Ivis, but with solid rollers, as the OEM chain has split rollers. These are solid ones, so it's a little bit better. But you see, I think I can extend the rod with a lot. So now I've done the clay test to ensure that there is proper clearance between the valves and the valve pockets in the piston, and also the squish band is sufficient. Squish band is, as you know, this area around here, flat and squeezing up against the cylinder head. It should be around 1.0, 1.1, something like it with this bore, but it's a tad too large. It's about 1.5, 1.6 millimeters. So that I would have to say is a mistake. But it will have to do for now, and next set of pistons will ensure that we get down to business. The important thing with having a proper squish band is that you force the combustion chamber further into the spark plug, and not doing any good around here, so that's why. But and also the valve pocket, the clearance here is over well enough. It's about 3 millimeters actually, and perhaps 1.5–2 millimeters radially. So that is totally okay. So assembly will continue. And I also spent half a day getting the proper valve timing. These camshafts, the cam sprockets, are mounted on cones on the camshafts, so they are fully adjustable, but nevertheless then you can try to fiddle with half a degree here and there, and it takes really a long time to get it right. Another thing I noticed here very late in the process was that the cam chain tensioner blade, the original one, was just about as long as it needed to be. So when the spacer here got in, the tensioner misses the tensioner blade just barely. So I had to get a tensioner blade that was a bit longer. So it's about 15–20 millimeters taller. So now I got the proper tension on the cam chain. And as you see, I've also lost the spring tensioner. I have it with a bolt instead. It's more safe in my point of view. So that's about it. And now I can show you also how I did the valve timing. Just very simple. Put a degree wheel on the engine and indicator on the crankshaft, and an indicator clock showing the valve lift, and that's about it. Well, built in a shed, so I use a shed tool. Black matches the sole of the driver, I'm told. You know, one of the characteristics with a thumper is that you only have one piston. So when the crank goes around, it is not very even in speed as it would be with a 4-cylinder bike. There will always be another piston pushing it down. So this a thumper goes a little bit uneven. It goes fast when it's going down and then slower. And that gives a certain uneven speed. That affects also the sprocket and the transmission. So as this is a bike coming from 250, a small bike, which doesn't have those kind of problems. There is no shock absorber integrated in the rear sprocket or anywhere else in the engine. But I definitely need it for a big thumper. So what I decided to do was that I fabricated my own hub here with these bolts on, and then I purchased a sprocket material. It's for a 530 chain. I'm using a 520, but I needed the thickness. So what I did was that I machined it down to 520, so I got the thickness in the material, and then I got some polyurethane material. I put it inside here, and also a small bushing, and then I put it like that. So it can, and also some Teflon water cut things, and also one of these on the outside, and then the bolt. So the sprocket can actually move around a little bit like this. This eases the pain on the whole transmission, the chain, the sprockets, the gears in the gearbox. Everything has a much easier life if you do some cush drive like this. So when you do your own super mono, think about it. Now the bike is almost complete. Engine is back in the frame with all the coolant hoses and a new gear lever, among other things. The only thing really missing now is something here to reduce the noise, or the music if you like. And I've been test started it a couple of times, but no film of that yet. When I get these on, I promise you. The race is up for a little more than a week, so all in good time. This is to do the end caps for the silencer. I have manufactured these two tools, and here is a steel sheet metal plate. So, and it's fairly greased in, so I'm just pushing it down like this to make it down to the bottom. Like that. And then take it off and clean off everything that's surrounding. And here is the final result. An end cap to use in either end of the muffler from sheet metal.